All right, my friends, we're moving right through Chapter 10. This is Section 4, Graphs of Higher Degree Functions. If you were to look through the section, you will notice it spends a lot of time talking about something called synthetic substitution. And I've taught that in the past. It's kind of like synthetic division. It is just a way to plug points in, plug x values in, and get a y value kind of quickly, better than just doing it all by hand. It is by hand, but it's not. It's just kind of a little system, and you can check it out. Since we are in the technology age, we will just find our points by using a calculator. I cannot imagine a situation in your life where you will ever need to use synthetic substitution. If I think of one, I'll go back and show you that. But your two goals for each of these questions is going to be to sketch a graph and to find all zeros. That includes real and complex zeros. This one, let's see, well, the questions in the book, they'll give you a domain of x's in which to try. This isn't one of those, so we'll just kind of look at a graph and make up the domain when we get there. So here's what you're going to want to do. You want to go to your graph and enter the equation. The table is where we're going to get all of our values, and I had previously set my table to go by 0.5s. It's not going to hurt to leave it there. The window, to make mine fit, I adjusted my window. I did y minus 100 to 100. What you'll notice with these higher degree functions is they get really big really quick, because if you raise 8 to the 4th power, you've already got a huge number that's way off the screen. So you might have to mess around with the window a little bit to make it fit. But this is my window when I go minus 100 to 100 in the y direction and minus 5 to 5 in the x direction. So it's very distorted. However, this lets me see all the important parts. So I think if I graph this thing from minus 4 to 4, I'm going to be in pretty good shape. So to make my graph, you are going to actually have to put your graphs on paper. I'm not going to make you do all the synthetic business, but you do have to at least, plot some points and make a graph. So let's see, minus 4, I'm at 175. So let's pick a good scale. Just working with graphs, the reason I'm making you draw these, just working with graphs is good practice, scaling and graphing, all that stuff. So let's see, I need to get up to, if I'm going minus 4 to 4, I can count by 2 boxes in this direction, make that one unit, 1, 2, 3, 4. And then in the y direction, I'm starting at 175, and if I go up to positive 4, I'm going to get to 111. So I need to get over 175 in the positive direction. And let's see, I've got 10 boxes in which to do that. So let's see, if I count by 20s, I will get up to 200, which will cover. So let's just call that 20. I can call that 1. And that should make it happen. All right, so negative 4, 175. So that would be 180. 175 would be just below 180. When I get to, going by a half unit would probably be even better. Negative 3.5, I'm at 95. So let's see, 20, 40, 60, 80, 100, a little bit below that. At negative 3, I'm at 48. Negative 3, 20, 40, about halfway between 40 and 60 about. And I'm going to pause and get this graphed for the sake of time. Pause. Okay, so I'm back with you, and that's graphing every half unit from minus 4 to 4, and you kind of get a nice idea of what the picture does. Notice this one comes down and it levels off and starts heading back up. Then it comes back down and we get our 2 zeros. This has 2 nice convenient zeros. One here at x equals 1, and that x equals 3. That's going to be important information for our next portion of this question. So there's the graph. You can do it on the table, but at least choose a nice scale and make a good picture. Don't just throw something down, just for the goodness of your math skills. Now, finding zeros. This equation must produce 4 zeros. So let me just get this and slide it over, and let's find those 4 zeros. During the graphing portion, I found 2 of them, x equals 1 and x equals 3. Now those facts are going to help us find the other two. We need to divide out the two factors that come from those zeros. This is that same idea that factors and zeros are connected. X minus 3 and x minus 1 are factors. If those are factors, that means they will divide out evenly. And I am going to do synthetic division on these factors to see what's left over. So let's see. First, I'm going to divide out the factor x minus 3. And remember, when you do synthetic division and divide by x minus 3, you put a positive 3 up in the box. Then my coefficients are 1. Don't forget the 0 for x cubed. Negative 8, negative 8, 15. Skip a line, draw a line, carry the 1 down. Then we multiply by 3, write the result here, and add. Multiply, get 9, write it here, and add. Multiply, get 3, write it here, get negative 5 when I add. Multiply, get negative 15, remainder of 0. That remainder of 0 tells me two things. First of all, that x minus 3 was in fact a factor, and that I have divided it out evenly. The resulting cubic, x cubed plus 3x squared minus x minus 5, that's what's left over when we take away one factor. Now let's take away the other factor. And by the way, you could have divided out the x minus 1 first. It doesn't matter which one you do first. So I'm going to put the 1 in the box now. And my coefficients are 1, 3, negative 1, negative 5. Bring the 1 down. Multiply and get 1. Add and get 4. Multiply and get 4. Add and get 3. And I just realized I did something wrong. This is going to be plus x, which makes that plus 1, which makes that 5. Because I was getting ready to get a remainder, and that's a good reminder for you. If your remainder is not 0, then something has gone wrong, like it just did for me. I, of course, did that on purpose because I wouldn't make a mistake like that. You know better than that. So anyway, x squared plus 4x plus 5 with a remainder of 0 is what's left over when we take out our two factors. Remember, our goal was to find the zeros. The other two zeros are going to come from this quadratic. Now, ask yourself this question. Should this quadratic factor? And hopefully the answer you're thinking of is no, because if it would factor, then we would have gotten more than two nice, neat zeros. We only got two zeros, so the other two have to be imaginary, which means we're going to do the quadratic formula and see what imaginary answers we get. So here we go. Negative b plus or minus square root of 16 minus 4 times 1 times 5, which is 20, all over 2. Or negative 4 plus or minus, that's going to be the square root of negative 4, which is 2i over 2. Or negative 2 plus or minus I. So remember, don't do too much. Your goal was to find all zeros, to sketch a graph and find zeros. So negative 2 plus and minus I, go on to that list. So my zeros, negative 2 plus and minus I, 1, and 3. If it's fourth degree, it has to have 4, and there they are, 2 imaginaries and 2 reals. A fourth degree, by the way, will never have 3 and 1. It will be 2 and 2 as far as imaginary and real. Imaginaries have to come in pairs, so you can't have 3. Otherwise, this graph needs to come in from the top left and leave to the top right. No way that can happen if that's not the case. All right, so ignoring the old school handwork that they wanted you to do, this is section 10.4, graphing and finding zeros. Do a little long division and a little calculator work, and that should do it. All right, I'll see you then. Young out.